I'm Qian. I'm a PhD student in HCI at Carnegie Mellon University. I'm a UX designer and a researcher. This is a project, my internship project at Microsoft Research last summer in collaboration with Justin Cranshaw, Saleema, Amershi, Shamsi, Iqbal, and Jaime, Teevan. I also want to quickly shout out to the NLP researchers we worked with at the Knowledge, Technologies, and Intelligent Experiences group. This work really wouldn't have happened without them. So the title of this work is called Sketching NLP. Let me unpack this a little bit. Buxton defines sketching as any design process that generates plentiful, disposable ideas that, with minimum detail. This is the fundamental practice of any user-centered design process. Designers generate many sketches, paper prototypes, in order to broadly explore the design space and identify the right thing to make before they go on to more high-fidelity prototyping, make sure to make the thing right. And here we're designing an NLP application. Here by NLP, I mean it in the broadest sense. Any sort of computational manipulation of natural language, from counting word frequencies to giving meaningful responses to human utterances. These technologies have, of course, developed explosively in the last few years, and researchers at Microsoft were really interested in how to harness these technologies to improve the user experience of word editors. We wanted to design an intelligent writing assistant. So following a typical user-centered design process, we started by started with an user study. We observed how writers write, from writing plays to novels, writing blogs, writing Kai rebuttals. Until we feel like we had a good enough grasp of the user needs and wants in writing, and we were ready to sketch. However, we still realized that we actually don't know how to sketch, how to broadly, fast and dirty sort of exploration of language-based interactions. Traditionally, user experience designers use storyboards so that we focus on exploring the right functionality to offer at the right time instead of the details of the interface. But when we design language interactions, I really don't know how to start without just writing down the whole script of the interaction. I don't know how to stay abstract when we were sketching. This is how we started this journey, trying to explore how to sketch an NLP application and learn to do so in the process of doing it. So I will share with you this story, and please nod aggressively if you had similar experience either as an NLP researcher or as a designer. So we wanted to stay abstract, and one of the tools that became really useful to us is this alternative format of wireframe, which we call the notebook. If you have experience using IPython notebook, you recognize the visual similarity. This wireframe offers a way of conceptualizing the moment when a user triggers an intelligent functionality. The user selects a part of the text and type in the functionality they want to apply to that text. And it is our design task to imagine what are the functionalities they would like to see when they try to type that. Of course, this does not mean that the users will eventually see an interface look like this. Rather, it is a way for us to conceptualize the design problem. We want to, for the moment, focus on envisioning the right functionalities to offer, rather than worrying about how it is triggered, when it is triggered, whether it's applied to the right text, and so on. For example, if the user types, we found that they often like to see some sort of auto-completion of examples based on the previous sentences. In the user study, we also found a lot of users write outlines in the format of a multi-level bullet lists, and later became a struggle with organizing these lists into a linear logic. So we thought, the users would like to see some suggestions of conjunction or transition words in these cases. So as such, we are able to quickly sketch a lot of potential functionality offerings to the user. And we identified about 20 ideas, and we had those ideas walk to the NLP researchers and say, hey, let's think about how to build these. And of course they said, well, none of this is buildable. I'm like, how come this is possible? We're an HCI researchers working in this space for a long while. These are the papers that use these techniques. So the researchers told us, well, those results are cherry-picked. You cannot trust those. And those works for those data sets, those techniques works for those data sets really don't quite translate well to other kinds of data. So we said, okay, if these ideas are not feasible, what is feasible then? And they were like, well, it's difficult to say. You need to look at the data and cannot quite tell. It's too vague. Your idea is too abstract. So we realized that the real challenge here is not just to understand how to grasp NLP's technical limits, but to understand how to work with data scientists without data at hand. Here is the solution. The solution that works for us. So we come back to this notebook representation of the design idea, and we say, for example, when the user types, for example, the immediate previous sentence is your runtime input. The rest of the documents can potentially be served as your training data. Let's also together brainstorm what other sorts of documents, for example, the documents in the user's computer or the text on the web, whether there are other kinds of text that can potentially serve as training data. If that's still not enough, let's together think about what additional information that would help your system to make that inference, such that we as interaction designers can help to elicit those information from the user designing in action to create those data. Once we presented this to the NLP researchers, they instantly became able to understand our abstract ideas. They no longer asked us to look at the data. And we were able to quickly bounce off many ideas, and gradually we also became more aware of the technical limits of NLP. In the paper, we described a set of rule of thumbs for other designers to use, such that they can quickly sort of gut check the technical feasibility of their design. So at this stage, we have become much more aware of what can be built, what cannot be built, and then we found ourselves becoming like we now think like data scientists. We really cannot think of any other idea left that's buildable and that's not autocomplete or autocorrection. And as designers, these ideas just seem rather unexciting. So how can we envision less obvious uses of available NLP technologies? We used a very classic design technique, which is called problem reframing. So far in the process, we have been thinking about the relationship between the system and the user as a writer and a writing assistant. But of course, writers know more about what they want to write than the system, and especially when they're writing a first draft. So we decided to reframe the relationship between the system and the user. What if we think about their interaction as a conversation, such that the system, although the system does not know what the user wants to say, but they can still have a meaningful conversation such that to inform the writing process. And similarly, we can also reframe this problem as translation problem, search problem, and so on. So we took these different representations of ideas to NLP researchers who focus on conversational AI, and we were able to explore a much wider range of available technologies that can be used to build an writing assistant. For example, although finding the right conjunction words of different sentences is technically difficult, we can actually build a new search function that helps users to retrieve the similar paragraphs online that have similar rhetorical relations. When we surface these search results to the users, they can use those paragraphs as reference and learn from those sentences how to organize their ideas into a linear flow. So this process led to a small set of ideas that we're confident that we can build, technically we can build, and also the users would appreciate. So then before we spend months or even years going out to collect the data, clean data, build a model, we wanted to do another set of prototyping activity. We want to probe the users to see if we are on the right track. But how? Machine learning algorithms are famous for making weird errors that humans cannot comprehend. And also, in HCI, we often use methods like Wizard of Oz, having people in the back end pretending to fake the behavior of the system to elicit responses from user. But in a commercial product setting, what the technology will produce is unlikely to be as good as a human response. So we spent a lot of time working with NLP researchers and come up with a new form of Wizard of Oz method. This is what we did. We asked participants to come into the lab, bring in the documents that they're already writing or they planned to write, and use our prototype. We asked them to type an at, so type a placeholder whenever they want to leave a task for them to later to do, or their collaborators or the machine to help them to do. And this is one example, what one participant wrote. Help me add this intro paragraph that's not too cheesy. Later on, when the user clicked on this instruction, the interface will provide the simulated output of our envisioned functionalities. But how to simulate error? For example, when we try to simulate paragraphing sort of functionalities, we put the wizard-generated perfect responses into a machine translator, translate it to Chinese and translate back. And in this process, a lot of the cultural context was lost, and we used that sort of imperfect response to simulate how in a context-aware sort of paragraphing functionality would behave. Another example is to fake the machine-generated text. We got a team of wizards, each of which played the role of one deep learning structure module. For example, one wizard will only see the overall document, but not the immediate context, the sentence right before or after user's instruction. That wizard will provide a response that's topically relevant, but not coherent to the rest of the document. Another wizard will see only the immediate context of the request, but not the larger context, and then wizard will generate a response that's only coherent, not topically relevant. And we have a meta classifier, a wizard who plays the meta classifier's role, combine these responses. By tuning the ratios of these responses, we were able to quickly probe how the users respond to many different kinds of machine errors. I don't have time to go through all of these, but we got a lot of interesting and weird responses that we were not able to get when we do observational studies or sort of controlled lab studies. One of the things, for example, when the writers saw the machine-generated text, sometimes they will say, well, this doesn't read right. That's one thing. And then there are times they say, well, the machine-generated sentence is really good. And I want to see the context. We're like, this is machine-generated text. What do you mean context? But they say, any text, the real meaning of any text is 2 paragraphs later. It's to write one sentence is always to seed an idea, a philosophy, like 2 paragraphs later. You will not be able to see the true meaning of a sentence until you read 2 paragraphs later. That's really something interesting to think about as sort of design, surfacing a machine-generated text to users. Another comment that came up repeatedly is whether this is plagiarism. We were lectured on how in middle schools, those participants were taught that you should not copy any texts for more than 5 consecutive words because that's not ethical. And they raised a lot of questions. If your response, if the system response is a synthetic sort of sentence coming from other people's writing, is this ethical? We don't have an answer, but I think it's really interesting for something for us to think a lot more about. What did we learn? This is a process. We went through a very, very typical user-centered design process. User studies, sketching, prototyping, nothing is new. However, all of the methods and tools we have in UX design have a strong graphical underpinning, storyboards, wireframes, paper prototypes. They do not apply to NLP sort of interactions. And HDI research on NLP has mostly focused on pushing the boundary of what NLP can do rather than what are all the design opportunities that's there based on what the technology can already achieve. The research also has focused more on how to make the NLP thing right rather than this initial process of how to broadly explore what is the right thing to make in the first place. So the challenges identified in this study really just a starting place for all those research questions, for the research inquiries along these lines. I think it's really important for us to think about how to abstract language-based interactions such that designers, especially like HCI practitioners who are translating the technical advances into real-world products, such that they can more fully explore the opportunities out there. I think it is also really important to think about how to enable not only closer but a more productive collaboration between NLP researchers and designers. There are a lot of research work also in this conference talking about we need a more closer, more tighter collaboration between the two expertise. But there are a lot more questions about design process that we need to answer. The collaborating with data scientists without data is just one example. Another example is we as designers often tell data scientists, tell me what you can do and how well you can do it so I can find the right place to use it. And the NLP researchers will say, tell me what the users would absolutely want so I can work hard to make that better. They're just constantly struggling with these methodological questions. I think there's also a lot of research opportunities around abstracting the experiential qualities of NLP interactions such that we can prototype and test the user experience of these systems before we spend a lot of resource and time building these. To summarize, this case study surfaced a range of research questions, I think, for us to explore, and the sketching tools that we revealed in the process, the notebook, wireframe, the prototyping methods, are really a first step answering these questions. And with that, I'm happy to take questions. Thank you.
All right, we have time for some quick questions.
Hi, thank you very much for this very interesting talk. I'm Stefan Schlögl from MCI. I was wondering, could you elaborate a bit more on the Wizard of Oz setting? Because if I understood right, you had several wizards working together, and my experience from Wizard of Oz is that this introduces lots of delay. How did you work with this? Thank you.
It has a lot of delay. Well, in the interface design is that the user can leave an @ sort of like a hashtag to leave the instruction there, and the response will only be surfaced when they click on it the next time. So there is a delay that's designed in the system. And also we found that we were very worried about the delay in the first place, but the writers seemed like they would like to write down a first draft first, and they can go through those to-dos much later. So that also allowed us more time in giving those responses. Another detail is that we, of course, went through those initial design process, so we didn't respond to any requests. We responded to mainly the things we know that the system can do, so we are prepared to do those tasks.
Thank you very much. A quick follow-up question? Sure. Did the wizards get any sort of training, and did you check for wizard consistency?
We didn't check the wizard consistency because it's a small set of participants and it's the same wizard. Mostly NLP researchers who had planned how to build those systems. So we fixed those responses accordingly.
Thank you very much.
Thank you.